Hi, everyone. It's great to be here at the stage and look at so many of you. So at Starcounter, the company where I work, we want to make software development super easy and super fast. And we mean mostly development of business applications. So we do this by removing obstacles in performance and productivity of developers. And this talk is about our approach to thin client applications on the web. So this is what we are going to do today. And I'm assuming you know things like HTTP, HTML, JSON, and WebSocket, and have some experience with single-page applications. So application protocols and user interface. Who thinks that they have nothing in common, they are unrelated? I don't see any hands. Personally, I think they are related, especially on the web, because for past 10 or so years, HTTP as the application protocol and REST as the architectural style has influenced the way we build web applications. Typical web application of today looks like this. Actually, there are two applications that we are dealing with. There is a server-side application that deals with database and business logic and some application logic, and it exposes a REST interface. And on the client, there is also an application which is responsible for user interface. And it has a REST client to the server. So they both use a JSON API, which is a contract between these two applications. And the thing is that we are using a stateless protocol to combine two stateful applications. REST was invented 15 years ago or so by Roy Fielding. And the architecture principle is very elegant and admirable, but it was designed to share resources on the web. And when we are speaking about building business applications, it means that we have to deal with hundreds of resource types and millions of resource instances in our applications. So it becomes very hard to manage. So typical problems in REST and resource-oriented architecture are the ones displayed here on the screen. So long-running transactions, data redundancy, and cache invalidation. This all comes from the fact that I always need to update server in context of particular resource. And when I save the resource on the server, it becomes available to everyone else. Because of these problems and also other problems, some companies have started to move away from REST. For example, still in this resource-oriented architecture domain, we have seen Facebook's Relay framework or Netflix Falcor, which deal better with exposing graph kind of data. But enough about REST, because I don't have a problem with REST. It has great uses. But what we are really fighting is the obesity of the client. So basically, all of the points here tell the same message. When you have code on the client that does something more than just showing pixels on screen, probably it duplicates some logic that is also elsewhere. And in case of web application, client-side code duplicates server-side code. And when it duplicates code exactly, then you only have performance problem and productivity problem. But when it duplicates the code almost, then you also have quality problems, and you have bugs, and so on. So we want to build real-time applications that are transaction-heavy, data-oriented. And I think that for such applications, thin client should be considered. At Starcounter, we have developed a pattern that we use. It's called Puppet.js. So it is a pattern for data synchronization. It uses JSON, JSON patch, HTTP, and WebSocket. And these are all standard technologies, so it works with any server. The server needs just to implement a view model pattern. And then this view model is exposed using these technologies. So how does it all work? Well, Puppet.js binds this server-side view model with an HTML rendering engine on the client. There is some HTML template, and the client puts the data from view model to DOM in your web browser. So we are now not speaking about two separate states of the client and the server. There's only one state that is synchronized using JSON and two-way data binding. And the whole application is controlled by the server. So to be more detailed, this is the flow. When you go to the web, from web browser to the server, of course, the initial request is HTML. But in our case, it just gets a small portion of code that is required to initialize a Puppet connection. And then we get the JSON representation of the user interface. So this is the mirrored view model from the server. And after that, every other piece of communication goes using WebSocket and just small patches to modify the view. This is the time for me to show it instead of just talk about it. So I have this application. Maybe I can actually show you this URL. If anyone can go to this URL, infoshare.mysampleapp.com, I have it as well in my mobile phone. Let's see if the network quality will be good enough. So first, a small example. Yeah, it works. So hello world example in our case is some full name of a person and then two input fields in the web browser. But when you look at the HTML source of this page, this is just it. And for every application, this will be almost the same thing. So this HTML loads some JavaScript and some web components. We use Polymer library from Google, but it is not required to be used. And actually one line of code, line 27, Puppet client. This one initializes the Puppet connection. And after the connection is initialized, we get a JSON representation from the server of the application. So this is all the data for the user interface. There is full name, and there is first name and last name. You can see first name and last name end with a $sign. In our pattern, this means that these values are editable on the client. So how do we put this on the screen? Because this is only data. Well, the HTML property, hello world/person.json.html, this is a template. And this is also a static file. So this is how it looks. And basically, this is two input fields, first name, last name. And the header, hey, full name, it is also a variable. So every change that I make on the client goes to the server. And when I change first name or last name input, server responds to me with change of the full name. And this goes in form of patches. So let's try that. Looks like someone is playing with me here. And yeah, you can see the patches are going. So they are very small messages. And for every request from the client, server can decide to push some patch in response. It can also push updates without any request, because WebSocket is duplex. And you can see numbers of messages in the communication, like 21, 22, and so on. This is required for operational transformation, so we never get out of sync. When server pushes asynchronously to the client, we sometimes need to compute, OK, so what is the actual state? And we kind of multiply the outgoing messages with the incoming messages. So it's always up to date. One kind of special thing, how do you send button clicks with JSON? We use a number for that. So here there is a button, save click, and when it is pressed, I increment the number in JSON, and server can have some code behind what happens when this number is incremented. So when I press this save button twice, you can see that here it was, the value is now 2. So that was a very simple demo, but of course, you can also build more complex apps with that. And JSON is very composable. You can have trees, and you can have nested trees, and so on. So this interface, it has some menu on the left and a current page on the right. And it is also represented as just a single master JSON document. So let's see at the source of it. This is a master template. It has a current page, navigation menu, and then my current page is this map, which has position. And if everything goes good now in my demo, I can show you some real-time qualities of it. So, demo time. Yeah, I am. Well, it worked for the first time. Let me try to reload the page quickly on my mobile phone. Yeah, basically everyone who's looking, it's not me right now, someone else is moving the pointer on the map. So if you go to this URL, infoShare mysampleapp.com, you can see that this value is synchronized. And for my app, there is no special code to do that, actually, not on the client side, because the template for this page is only this. There is a web component from Google using Polymer two-way data binding. You see there is, I have this Google Map element, and inside of it I have Google Map marker element. And it binds to current latitude and longitude. So in my application, these patches come from the server, and they're just pushed to the client. So we kind of get real-time application for free because of using thin client. Of course, we also use objects and arrays in JSON. So to have complex user interface elements like this breadcrumb navigation, every item in breadcrumb is an array. Well, actually, it is here. Yeah, so this is an array of objects and things like autocomplete and so on, where you have a request and server pushes some response, maybe asynchronously, become very easy to do. So this element here, it is quite complex, but it is all expressed in JSON. So this is the code for that element. There are items on the breadcrumb, and basically this drives my whole user interface. So how does it all work, and why does it work? Well, there's one thing about JSON. JSON is pretty low resolution format. It has only 6 types of value, right? And we find this is an advantage of it. And when you compare this to what fat client frameworks are doing, like Angular or React, they load JSON, and then they parse it, and they rebuild the data model from it on the client. So they need to know that this string is a first name, another string, this is last name, and so on. And we don't do that. We just use this as it is and put it to DOM. So Puppet.js is more like a remote desktop, but instead of sending pixels, we send patches. And we keep everything dumb, stupid on the client. We don't care what it means. So there's plenty of benefits. We care mostly about benefits to productivity. So of course, there's no app on the client that you have to write, and there's one app less to write. And there is also no glue code between these apps. It works great with JavaScript and web components, because this object on the browser, it is just a JavaScript object. And now you can apply it to a charting library or a data grid and so on. D3 visualization, it just takes a JavaScript object as an input. And we have it directly from our JSON, so server can dictate changes in it. And of course, complex UI has a lot of subtrees, as you have seen in this example, but it is not that you have maintained this big JSON on the server side, because we have ability to compose it out of small nested JSONs. So there is a bunch of very, very, very narrow JSONs, and they are combined together to create this big view. Benefits to performance, we can morph the views. So when you see a user interface, and due to the actions that you make, small part of it gets replaced with some other part, of course, the whole page is not reloaded. We just replace this small part in JSON as a patch. And the patch includes new HTML template if needed. Then this part is reloaded. Otherwise, it only replaces the data. Server can push data to the client, as you have seen. And server can not only push changes of primitive values, like position on my map, this is just 2 numbers, but actually the server can also push a change of view. If server, for some reason, thinks I should be looking at the dashboard right now because there is a fire or something, then server can force me to see something else by replacing my current view. And the other way around, real-time connection works 2 ways. So when you have a form on your page and you type first name and you unfocus the field, this information already goes to the server. So then you type last name and you unfocus the field. The information is already on the server. When you press submit in the end, you only have to send the information that you submit to that form, because everything else is already on the server. So this mitigates network latency. You don't send things in bulk. You send them one by one. Benefits to integrity, security. Well, I think less code to write means less code to maintain and potentially less vulnerabilities, because now there is only one piece of code that you need to care about to make your application secure. And in our case, server is the application. So server is the single source of truth. And the patches from client to server are just proposals of changes. And server can say, no, you cannot do that here. Or server can say, OK, thank you for changing the first name. Here is the updated full name in response. As I mentioned before, operational transformation, this is something you have seen in Google Docs or places like that, where multiple people are making changes to the same document. There is an algorithm that solves the conflicts. It sorts the patches and applies them in correct order, so you don't have conflicting patches in your session. Right now, there are just implementations that come from us, Starcounter, and because Starcounter supports C# as its first platform, then the server-side implementation is C#, and the client-side implementation is JavaScript because we use it in a web browser. But it should not be limited to that. So we are working right now on a Node.js server version, and the C# version will be soon released as a separate project on NuGet. So all I presented is available on GitHub with the specification, as well as the sample apps are available on GitHub as well. And pretty much that's it from me. So thanks for listening. That's my favorite slide. No standards were harmed during this presentation. So thank you. If there are any questions, I will be happy to answer them.
Thank you, Marcin. Actually, we have one question from Maciej. Doesn't Puppet.js make strong coupling between server and client and make it difficult to manage the coupling?
Well, it makes coupling on purpose. So maybe I should tell you a little bit more what Starcounter is. Starcounter is a platform for building what we call micro apps, similarly to microservices. And in our case, when you want to have 2 different views, that is completely different roles, then this is completely different applications. So in our case, the coupling is, if you want to have 2 applications, write 2 applications on the server, and in Starcounter, they use the same data, because they run in the same database, and it is in memory. So in our case, this is intentional coupling of the server and the client, because for us, an application is just one thing.
OK, thank you. I think that answers the questions.
Thank you. Bye.
Thank you, Marcin.